Voyager 1 launched more than 40 years ago and is now entering a mysterious and unexplored part of space, revealing secrets that unsettle even the most seasoned scientists. Built using simpler technology, this old spacecraft continues its journey billions of miles away from Earth. As it ventures into the unknown, it makes discoveries that challenge what we know about the universe. What strange truths lie hidden in the depths of this universe? Explore the shocking discoveries of Voyager 1 on its 45-year journey beyond the stars. And just when you think his story might be fading away, he surprises us with a signal that challenges his technological age. Conceived in 1977, the mission did more than just push boundaries. She broke them. Now, prepare for a chilling discovery that will redefine the impossible. What's next for Voyager 1? Stay tuned for more details. In 1965, something incredible happened in the world of space exploration. Two spacecraft were about to embark on a journey that would change everything. At the dawn of the space age, Gary Flandreau, a talented engineer at NASA's Jet Propulsion Laboratory, was faced with a difficult task. He had to find the optimal path for his spacecraft to visit the distant gas giants Jupiter, Saturn, Uranus, and Neptune. Armed with only a pencil, Flandreau made a groundbreaking discovery. He realized in the late 1970s and early 1980s that all four planets would align perfectly in the sky, creating a rare space path. This alignment meant that a spacecraft could use the gravity of each planet to speed up its journey, traveling from Earth to Neptune in just 12 years instead of the usual 30. But this alignment was a once-in-a-lifetime opportunity. It only happens once every 176 years. NASA knew they had to act quickly. This mission was perfectly timed to take advantage of this unique planetary alignment. What no one could have predicted was that these probes would continue to make history. More than 40 years later, Voyager 1 and Voyager 2 are still traveling further into space than any previous spacecraft. They continue to send us invaluable information, helping us learn more about the universe and revealing new surprises along the way. These machines have lasted and traveled much longer than expected. They were originally supposed to operate for only 4 years, but they have far exceeded that time frame. Along the way, they continued to surprise us. First, they sent us amazing pictures of the moons of Jupiter and Saturn, showing us that these distant worlds were much more vivid and dynamic than we had imagined. We saw volcanoes erupt and ice caps move, and everything we thought we knew about these distant planets changed forever. Voyager 2 was at the forefront of this research, becoming the first spacecraft to fly close to Uranus in 1986 and zooming past Neptune in 1989. It remains the only spacecraft to have traveled this path, revealing new information about a region more than 14 billion miles from Earth. About the size of an old Volkswagen Beetle, this space probe has surpassed all expectations and continues to expand our knowledge of the universe. The Voyager mission began with a gravity assist maneuver on Venus, a technique that had never been used before, as they set out to explore Mercury. This made them pioneers in space exploration. But it wasn't easy. The margin for error was incredibly small, success or failure was determined in minutes, and it often took several attempts to get the right result. The first route to Jupiter was 10 times farther from Earth than Mercury, and required passage through the dangerous asteroid belt, a hotly debated topic in the 1970s. Fortunately, earlier missions like Pioneer 10 and 11 safely passed through this dense region, paving the way for the Voyagers. But the Voyager's test run is far from over. By tracking the signals from distant Voyagers, we uncover the secrets of deep space. Voyager spacecraft, which travels to the unknown using just 69 kilobytes of memory, far less than a smartphone, had to be smart to manage all the tasks required to carry out its mission. The data they collected was stored on 8-track tapes and then beamed back to Earth using transmitters as powerful as the light from a refrigerator. Equipped with a 12-foot dish antenna, the spacecraft communicated via radio waves traveling at the speed of light. But because the Voyagers were billions of miles away and moving farther away every second, maintaining communication was difficult. For example, it took more than 18 hours for Voyager 2 signal to reach Earth. And as the number of signals from Earth increased, radio, television, cell phones, it became more difficult to detect the weaker signals coming from the spacecraft. Despite these challenges, Voyager continued to defy fate and send back new and amazing discoveries from the far reaches of space. Their research has transformed our understanding and expanded our knowledge of the vast, unknown regions beyond our solar system. Far beyond lies the Oort cloud, a mass of icy objects held together by the sun's gravity. It extends nearly halfway to the nearest star and is where Voyager is slowly approaching. The edge of our solar system, the heliopause, marks the boundary where our solar system ends and the wider galaxy begins. Before the Voyager spacecraft reached the planet, estimates of its distance varied widely, but many believed it was about 50 astronomical units away, which increased support for the mission. As Voyager continues its exploration, it is helping us better understand distant regions of space and giving us glimpses of places we have never seen up close. But some signs have puzzled scientists. In particular, they have been looking for increases in cosmic rays, high-energy particles produced by events such as supernova explosions that travel nearly at the speed of light. Normally, such increases would mean that the spacecraft has entered interstellar space. But that hasn't happened. Instead, most of the low-energy cosmic rays have been blocked by the heliosphere, a massive magnetic barrier that protects the inner solar system from the dangers of outer space. The team monitoring Voyager also paid close attention to changes in the magnetic field. As the spacecraft moved away, interstellar space, filled with charged gas and shaped by the magnetic fields of nearby stars, exhibited different magnetic patterns than those found inside the heliosphere. But no changes were detected, which puzzled scientists even more. Only after Voyager 1 crossed the edge of the heliosphere, the heliopause, did it begin to send back to Earth interesting data that confirmed the expected increase in cosmic rays. This moment provided important insight into what interstellar space is really like, and highlighted how unpredictable and difficult space exploration can be. The magnetic field around Voyager 2 showed no signs of change, which was surprising. People generally thought that the magnetic field would change direction as it moved from the part of space influenced by the sun's magnetic field to the space formed by another star. In November 2018, Voyager 2 began its remarkable exploration of the edge of our solar system, known as the interstellar boundary, reaching the heliopause, 120 astronomical units, AU, from Earth. This was the same point that its twin had reached 6 years earlier, but Voyager 2 found no changes in the magnetic field, contradicting existing theories and making the situation even more mysterious. Experts had expected that the heliosphere would contract and expand like the solar wind according to the sun's 11-year activity cycle. But none of the current theories could explain the strange results, especially since the solar wind was unusually strong when Voyager 2 arrived, suggesting that the heliosphere was farther away than 120 Australian dollars. Eek from Earth. As the Voyager probes approached interstellar space, they began to notice small fluctuations near the heliosphere due to interactions within the heliosphere. However, from a distance, the magnetic field appeared quite stable. These differences led to a debate about whether the spacecraft would eventually leave this chaotic region and find a real interstellar magnetic field, or whether the current models were simply wrong. Some scientists believe that the Voyager probes may still be inside the heliosphere, while others, convinced by the rapid increase in galactic cosmic rays and plasma density recorded by the probes, believe that they have begun to enter interstellar space. This new data addresses one of the major questions in space exploration today, sparking ongoing debate among experts. Understanding the heliosphere is like trying to see the entire room from inside an aquarium. To truly understand it, we need a probe that can see the solar system from deep space. Unfortunately, despite being a departure from old technology like VCRs and answering machines, the Voyager spacecraft are still fighting against all odds. They use technology that is over 50 years old with very simple software. The original engineers kept it simple, not using complex code. Today, Voyager 2 still has 5 working instruments, and Voyager 1 still has 4. The spacecraft are powered by a device that converts heat from the radioactive decay of plutonium into electricity. But they lose about 4 watts of power each year, so NASA has to decide which systems to keep running to conserve energy. Just 3 years ago, engineers had to turn off the heater on a space probe that was crucial to determining when the spacecraft was leaving the heliosphere. It was expected to stop working in the cold space, but it kept on working, an impressive feat considering it was much colder than it was designed to be. The magnetometer and plasma science instruments are housed inside the spacecraft's main body and are likely to be the last to shut down because the computer's heat keeps them warmer. All other instruments, the Voyager mission is now in a difficult position. Engineers are trying to fix a flaw that is causing Voyager 1's data to be confused with ground systems. They are trying to figure out if they can fix the problem. 14.6 billion miles from Earth, it takes more than 21 hours to transmit even a simple signal. Voyager 2 is 12.1 billion miles away and is still communicating, which shows how important the ongoing mission is. These old spacecraft remind us of the spirit of exploration and the desire to keep moving forward even when faced with the unknown. They push the boundaries of space science and inspire us to continue exploring the universe to find answers to our greatest mysteries. Despite being launched in the late 1970s, Voyager continues its incredible journey. Located 14.7 billion miles away, it gives us a glimpse into the hidden secrets of the universe and occasionally reveals surprising things. When scientists discovered a very low-frequency hum coming from space, they discovered that Voyager 1 was picking up the hum of plasma waves, confirming that our little spacecraft is still discovering new information about the unknown. Voyager may soon leave us as its power gradually fades, but its legacy will live on forever. Even if the spacecraft loses power, it will continue to drift and travel for millions of years. It is an amazing reminder of humanity's incredible achievements and endless quest for knowledge.